So as we move into Unit 4, we're going to talk about some geometry topics, lines and angles to start with. Again, you may be familiar with some of this material already from your classes back in high school. If not, though, we'll just kind of refresh you on some of the vocabulary. So when it comes to geometry, one of the basic terms we have is, let's see this to work here. We have the word point. So a point is a location or position that has no size or dimension. So remember, like on maps, cities and things like that, we use like a point or a dot to represent that point. So again, like I said, a dot, or sometimes we just call it a point to represent that location. A lot of times a capital letter is going to be used to label that point. So again, a capital letter is going to be used. So the next thing we have is what we call a line. A line extends indefinitely in both directions and contains an infinite number of points. It has a length but no width. In our discussions, the word line always refers to a straight line unless otherwise specified. So what's interesting is, there are different types of geometry. We're looking at what's called Euclidean geometry. There's also geometries out there that are non-Euclidean. If you ever Google that, look it up, you'll see that a line can be defined differently. But the line we're talking about is one we're more familiar with, which is a straight line. So when naming a line, usually a line is named by 2 points. So 2 capital letters that the line passes through. Another vocabulary word is this word plane. A plane is a flat, smooth surface that extends indefinitely in all directions. A plane contains an infinite number of points and lines. So these would be some images here. A point is just a dot and we can label this like point A. We have this line. Since it passes through these 2 points, we'd call that line AB. And then we have this plane. A lot of times planes are also named by capital letters. So, I could say this is plane P or something. It doesn't have to be a P, it could be anything. But notice that P is actually a surface. So think of your table as a plane, but the catch is a plane is more abstract. The plane itself actually has no edges. It extends forever in all directions. Also, a plane does not have actually a specific thickness. So a plane is a much more abstract thought, but that would be a general ideal for us, is just simply a surface. So we have a line segment, or sometimes we just call it a segment. It's going to be part of a line. It starts and stops at distinct points called endpoints. So notice how a line has these arrows on the ends. That means it does not end. It continues off in both directions. So a line just continues off in both directions with no specific length. A segment, though, notice how it has endpoints. There's a point A and a point B that make endpoints. So the segment AB would have a specific length that we can measure. So this is the notation a lot of times we use for line, is we'll draw like a little line with arrows above it to represent line AB. If we just draw a little dash without the arrows on the ends of it, that's described as a segment AB. Now, segment AB, you could also call it segment BA. They would still be considered the same segment. So direction really doesn't matter how you label that, but typically AB sounds better. So we also have what's called a ray. A ray has an endpoint, and then it continues off in one direction. So if it passes through this point B, we could call this then ray AB. So that's the main topics you'll kind of come across as we move on. Points, segments, lines, rays, those will be the big ones. So if we look at this example here, we want to look at this figure over here, figure 7.5, and notice how we have some lines going across here. We have some points, but also hidden in those lines are line segments and rays. So question A says, name a ray with an endpoint of Q and passing through P. So if we look at that, on our graph, we kind of see Q is its endpoint, and it passes through P. So if we want to name that, the name of that would just be ray QP. So you put the endpoint first and the P second. So ray QP would be the name of that. So question B, do line LM and line MN represent the same line? To be the same line, they have to be on top of each other. So notice how LM is going in one direction and MN is running in the same direction. So notice how they actually represent the same line. So because L, R, M, and N are all on the same line, so that does represent the same line. So yeah, that's true. Question C. Does line segment PQ and line segment QP represent the same line segment? We just talked about that. Yeah. P to Q, let me get my eraser out here, get this off here. So P to Q would be from here to here. Q to P would be from here to there. So notice that we're talking about the same line segment. So yeah, that's also true. So if I look at question D, name two lines that are parallel. So parallel means they run in the same direction. We really only have three lines. So the two lines that are running parallel would be this line RS. So line RS, and that would be parallel to line PQ or QP. So that would be the two line segments. You don't have to actually put the parallel symbol there. All you got to do is really just write line RS, comma, PQ. So next thing we get into are what we call angles. Angles are basically, you have this vertex point and we have two rays extending from that vertex point. So vertex point also kind of means endpoint. So if I look at this point P, notice how it has these rays extending from it. So that would be an example of an angle. The angle, there's two ways of looking at it. The angle here, most of the time we look at the interior part of it. So this would be what we were talking about, is what's inside there. Typically, it doesn't have to be that always, but that's where we'll start out at. So that would be an example of an angle. If I look at P again, notice how I can kind of go here to here and here to here. So notice how we have the same endpoint, which is called the vertex, and we have these two rays extending from it. So that'll be our angle. So we could look at it from that perspective. So notice how angles can also be named by, they can be named by numbers. So this one I traced in blue would be angle 2. The one I traced in green would be angle 4. So that's kind of what we got going on here. Notice how we have this, what's called the vertex point. So that shared endpoint, and we have these two sides that extend from there. So they don't have to be rays. They just have to be these, most of the time, you know, how that we do draw with rays, but they don't have to be rays. They can just be from here to here as well. It doesn't have to extend all out. So sometimes we call them sides or legs as well, with that respect. So a lot of times, like when you talk about shapes, you know, squares and rectangles and triangles, we use the words sides or legs in those shapes. Probably for squares and rectangles, we use the word side more so, but with triangles, we sometimes will also use that word leg associated with that. So again, the angle is actually typically this inside part. That's going to be our angle. But an angle can also be defined from the other side of it. This part here could also be described as the angle. So, but most commonly when we talk about the angle, we're talking about the interior angle that's between the two sides, not the outside of it. So when it comes to angles, you know, Notice how we have this rotation. Most of the time, our rotation in an angle will be like what we call counterclockwise. And when we rotating is kind of a degree measure. So degrees, or this is the degree symbol, will be used. So as far as this angle goes, we could call this angle 1. We could call it angle L. We also could call it angle KLM. Or we also could call it angle MLK. If I use 3 points, the vertex point has to be in the middle. So if I use 3 letters, that vertex point has to be in the middle. So if I look at this angle here, we could call this, we can call this angle Z, or we could call this angle A. If I use 3 letters, I could say angle XZY. Again, notice how that vertex is in the middle, or we can go Y to Z to X. So angle YZX would be another way to describe it. So an angle can be named 3 different ways: by a number, or a small letter, or by the actual points on the line. If there's only one angle present, we can use 1 letter. But if there's multiple angles present, then we have to use 3 letters to kind of describe it. So notice, as I was saying, we have this, when I have this angle P, there's 2 ways of looking at it. We can look at angle P as this outside angle, this outside rotation, or we can look at it from this inside rotation. So most commonly, we'll be looking at it with respect to this. But there's 2 angles present. There's what's called the interior angle and also the exterior angle. So, but again, we're going to be mainly focusing on the interior angle, but who knows? They may throw a questionnaire about exterior. So again, I can name it as angle P, or I could also name it with 3 letters. I can name it as QPR, or angle RPQ. Angle RPQ. Notice again, the vertex has to be in the middle. So I could kind of go Q to P to R, or I can go from R to P to Q. But notice how an angle has this vertex point, and it has to have these 2 sides. Usually, one side will usually be called the initial side, or the starting side. So we'll keep that in mind as we move forward, the initial side of an angle. So if I look at this example here, name the angle with 1 capital letter. If I name it with 1 capital letter, it has to be the vertex. So since X is the vertex, this will be called angle X. Name the angle with 3 capital letters. If I do that, remember the vertex has got to be in the middle. So if I go from Z to X, from Y to X to Z, that would be one way to name it. So Y, X, Z would be using 3 capital letters. C, name the angle with a number. So notice how there is a number here, so we can name it as angle 1. That would be 3 ways to name this angle. As we mentioned, the customary rotation around the point progresses opposite the normal rotation of the hands on a clock. So remember, the hands on a clock are clockwise and counterclockwise. Notice how the hands on the clock are typically going in this direction. All the hands are moving in this direction, which is considered a clockwise direction. But when it comes to angle measure is actually considered, the primary direction is what we call counterclockwise. So if you're going counterclockwise, this is described as a positive direction. So if I'm going in a counterclockwise direction, that angle will be represented by a positive value. But notice how here, the angle is going in a negative direction. I'm going clockwise. If I'm going clockwise, we have to use a negative number to represent its measure. So keep that in mind. Angles can be positive and angles can be negative depending on which direction we go in. So most commonly, we like to go counterclockwise. So we like to use positive angles. So we have to be going in that direction. So if you notice all these arrows up here, they've been going in a counterclockwise direction, the positive direction. So a lot of this will get transposed onto the coordinate plane. So remember, a coordinate plane is basically got 4 right angles in it. So we have this first quadrant, we have a 90-degree angle. The second quadrant also has this 90-degree angle in it. The third quadrant, I'm sorry, also has this 90-degree angle. And this fourth quadrant also has a 90-degree angle. Remember, when it's a 90-degree angle, we actually use it like a little box. So remember, if I have a right angle, if it's a 90-degree angle, we use a box to represent that. So this rotation here is described as 90 degrees. Now remember, if you go completely around a circle, if you make one complete revolution, 90 plus 90 plus 90 plus 90 plus 90, that is going to be 360 degrees. So remember, rotation, a full circle or a full rotation is 360. But if I don't go a full rotation, then we are going to be under 360 degrees. So notice that if I just rotate from here to here, that's actually considered a fourth of 360, or in other words, we call this 90 degrees. So after a while, we just notice by the shape of the angle that what its measure is. We get familiar with it. So some other vocabulary words is we have what's called a straight angle, acute angle, and obtuse angle. So we have the straight angle, acute angle, and obtuse angle. A straight angle measures halfway around a circle. So it's like a semicircle. In other words, this is going to be defined as a 180-degree rotation. So notice how we have a straight angle represents 180 degrees, or half of a circle, or 1/2 complete rotation. An acute angle is less than 90 degrees, but it's more than 0 degrees. So notice how here we're going in a rotation. But remember, a full 90 degrees would be up to this side. Notice how if one side's horizontal and one side's vertical, that creates what we call a 90-degree angle. So this angle here is not quite 90 degrees. It's between 90 and it's between 0 and 90. So we call those acute angles. So these would be some examples of some acute angles. An obtuse angle is going to be more than 90, but it's going to be less than 180. So an obtuse angle, so notice how here's the straight angle, here's the right angle. So notice that this angle goes past 90, but doesn't make contact with the 180. So obtuse angles are considered angles between 90 and 180 degrees. So remember, the word acute is usually associated with little. So acute are the small angles, less than 90. Then obtuse kind of sounds thicker. It's going to be the one between 90 and 180. So remember, if we are at 90 degrees, that is a right angle. So if we look at these angles here, examine the angle to determine the number of degrees it measures. First, we want to classify the angle as a right, straight, acute, or obtuse based on its degree measure. So if I look at angle 1, notice angle 1 is from here to here. Does that look like it's less than 90, 90, more than 90, or is it like a straight line 180? Well, to me, this is a small rotation. This is a small angle. So this would be classified as an acute angle. If I look at angle 2, notice how it goes from here. It goes from here to here. Notice that that's a much wider angle. And remember, 90 degrees would be about here going across. So 90 degrees would be about here. So notice how that's kind of going past 90. This is going to be classified as an obtuse angle. If I look at angle 3, notice how it looks a whole lot like angle 1. That's going to be an acute angle. If I look at angle 4, it looks a whole lot like angle 2. So it's also obtuse. So if I look at angle 5, angle 6, angle 7, angle 8, notice how those all look like they're right angles. So those are right angles. So right angle, I should say, right angle, or just simply say right. So remember, right angles measure 90 degrees. So notice how we use kind of a square as our notation there, that little square there. So notice at angle 9, notice how it goes halfway around. We call that a straight angle. So angle 9 would be a straight angle, and a straight angle measures 180 degrees. So these are all 90 degrees. Notice how this is less than 90. This angle is between, so if I call it angle 1 or angle 2, so angle 2 is kind of between 90 and 180. Something like that wouldn't be bad, but so another vocabulary words we have is what we call complementary angles and supplementary angles. Complementary angles is when we get into angle pairs. So if two pairs of angles add up to 90 degrees, they're said to be complementary. Since 40 plus 50 is equal to 90, we call these complementary. They complement each other. Another word we have is the word supplementary angles. Notice that we have these two angles, 60 plus 120. These angle pairs add up to 180. So if two angles add up to 180 degrees, we call them supplementary angles. So if two angles add up to 180, we describe those as supplementary. So to find the complement of an angle, remember the two angles have to measure up to 90. So to find the complement, we actually subtract from 90. To find the supplement, since two angles add up to 180, to find the supplement, we have to subtract from 180. So if I want to find the complement, the supplement of the angle that measures 57 degrees, so remember, a complement, we're talking about right angles. So if we have a 57 degrees is this angle, then we're looking for this angle over here, its complement. So remember, they both have to add up to 90, but the easiest way to do that is if you just go 90, take away 57, that'll give you the complement. So 90 take away 50 would be 40, take away 7 more would be, 33? Yeah. So supplementary means that we have the straight angle involved. So if I have this 57-degree angle here, the complement is the part that we have to add to that to get the 180. Easiest way of doing it is go 180 take away 57. So 180 take away 50 would be 130. Take away 7 would be then 123. So 123 degrees and 33 degrees. Another special pair of angles we have are called vertical angles. Vertical angles are formed when two lines intersect. The angles that share the common vertex, but not a common side. A lot of times we'll call them opposites of each other. So notice how angle 2 and angle 4 are opposite each other. Notice how angle 2 has these two sides. Angle 4 has these two sides. So notice that they don't actually share a side. So we call those opposite angles. So angle 2 and angle 4 would be equal. Sometimes in geometry we use the word congruent. And angle 1 and angle 3 are also considered equal, or we use this word congruent. So notice how angle 1 and angle 3 are both acute. Angle 2 and angle 4 are going to be both obtuse. Also notice that angle 1 and angle 2 create a straight angle, so they'd actually be supplementary angles too. So we have a couple of different pairs there, but they were just talking about vertical angles. So another word they talk about is the word adjacent. Adjacent angles are two angles that share a common side. So notice how angle 1 and angle 2 would be adjacent angles because they share this side right here, that common side. So angle 1 and angle 4 would be adjacent because they share this side right here. So angle 4 is here. Angle 3 is here. And notice how they share this common side right here. This side right here they share. So we call those adjacent angles if they share a side. Okay, I'm gonna pause there and we'll do another video on converting angles, degrees, minutes, and seconds.